Section 6.4, Polar Equations. This is our last section this semester, and this is going to be our last application of trigonometry. So a point P in polar coordinates is a point of the form r comma theta, where theta is an angle whose initial side is the polar axis, which is the positive x-axis, and has terminal side through the point P. R is going to be the directed distance from the pole, or the origin, to the point P. Now this setup should sound pretty familiar to you. You've been doing a lot of things like this, where we measure this distance R from the origin to the point P, and we look for the angle theta from the what we're now calling polar axis to that terminal side. You notice this graph that I have drawn here is a polar grid. So I've got my angles marked, pi over 6, pi over 3. We could also mark the pi over 4, and so on around the outside of the circles. And I've got a bunch of small, lightly shaded circles of varying radius. And that's just going to help me to plot my points in polar coordinates. So this point P that I've drawn here is the point 4 comma pi over 6 in polar coordinates. So what that means is that this point P, the angle that we travel, is pi over 6, and then we move 4 units from the pole in the direction of pi over 6 to get P. Now, that's not a unique way to describe this point. So there are lots of angles that I could use there. If I fixed my R as 4, that would get me this point P. I could also change the 4 to a negative 4 and use an angle down in quadrant 3. So let's try to give some more descriptions in polar coordinates of this point P. So as I said, I can use any angle theta whose terminal side passes through the point P. So what if I just add 2 pi to pi over 6? So the point 4 comma 13 pi over 6, I would travel 2 pi and then another pi over 6 to get 13 pi over 6. And then I would move 4 units, so R is 4 here. And that would put me right at my point P. Well, negative 11 pi over 6 is another angle that's coterminal with pi over 6. So the point 4 comma negative 11 pi over 6 also describes our point P. And as I said, we could instead change the 4 to a negative 4, and now I want to pick an angle in quadrant 3. So the negative 4 is going to say, well, here's 7 pi over 6, but I want to go in the opposite direction of that, so that's going to shoot me up here 4 units, and that puts me back at my point P. All right, so let's try plotting some points in polar coordinates. So we're just going to use this grid that I have here. The first point I want to plot is 2 comma 3 pi over 4. So the first thing I want to do is think about where 3 pi over 4 is. It's over here in quadrant 2. And I want to move 2 units from the pole in the direction of 3 pi over 4. So that's going to put me on this circle of radius 2 right here. So here's my point 2 comma 3 pi over 4. What about negative 1 comma pi over 3? So pi over 3 is here in quadrant 1. And if I want -1, I'm going to shoot down into quadrant 3 in the direction, sort of the opposite direction of pi over 3, 1 unit. And so that's going to put me right here. So I have -1 comma pi over 3. Now what about 3 comma -pi over 4? So -pi over 4 is an angle in quadrant 4. Here it is, -pi over 4. And I want to move 3 units in the direction of that angle. So 1, 2, 3 puts me right about there. 3 -pi over 4. And finally, we want to draw -3, 13 pi over 6. So 13 pi over 6 is coterminal with pi over 6. And I want to move -3, so I'm going to go down into quadrant 3 again. And 3 units. So here we go. -3, 13 pi over 6. Now you should practice plotting some polar coordinates yourself. It takes a little time to get used to thinking of this in terms of r and theta. You're used to thinking in terms of x and y. But hopefully with all of the trig that we've been doing this semester, this isn't too much of a stretch to switch to r and theta. I want to show you an example here with the Desmos website. So let's open it quickly. Now this is linked in your notes. So if you open your notes on your computer, you should be able to click on the link, or you can just cut and paste or type in the URL for this. Okay, so you might want to open this up on your computer as you watch the video so that you can play with it yourself. So what I have here are 2 points that are plotted on my axes here. The first point is in polar coordinates. Here instead of using radians, we're using degrees for our angles, and we've called the angle A instead of theta. So point 1 is r comma theta, or r comma A, and it's going to be the red point. So watch as I move the r value here. So my A is at 60 degrees right now, and as I move r, you can see the point moving further out as r increases and further in as r decreases closer to 0. When r becomes negative, we shoot down into quadrant 3 here. Now what if I fixed r and changed the degree? So I was at 60. If I shoot to the right to 75, and here I keep moving, you can see what happens is I'm moving along the circle of radius 3 here. My r was 3. Now the blue point is in rectangular coordinates, so x comma y, and I can move this point too by changing the x and the y values. So if I change the x values, that's going to move the point left or right. And as I change the y values, that's going to move the points up and down. Okay, so the question is, can you adjust the x and y values, or the r and a values, to make the points match up? So what I'd like you to do is stop the video and open this up on your computer and try moving that around to see how the points line up. And we're going to use that to help us figure out how to switch between polar coordinates and rectangular coordinates. So So go ahead and do that and then come back and watch the rest of the video.